Roman, if you'd like to take it away.
Oh, I'm doing the first ones. Okay.
Yeah.
I was doing the later ones, but yeah, sure. Um, some common rig breaks is double transformations. And those are usually found with like global scaling or sometimes when performing a rig's regular functions of translation or rotation. It's basically when a portion of your rig has its transformation data repeated a number of times despite inheriting those transformations only once. And a cycle is almost like that, but this more so occurs like, this can happen in stretchy legs when you have a series of inputs going in a circular fashion. For example, if I have three objects and constrain them to each other, then they'll each cause Maya a warning. Yeah, that will cause a Maya warning to pop up and will make the rig unusable. But it's basically like those two things are basically parts being influenced by other parts that kind of break it. And so fixing double transformations is oftentimes your double transformations will occur due to the destination object having multiple inputs funneled into it. And sometimes it's transforming while having another group transform place into it. In the case of an IK spline handle, if you scale it, the curve is scaling while inheriting additional scaling values of another object. So you'll want to turn off inherits transforms in your attribute editor. But do be careful with that though, because sometimes that can cause issues on its own. In many cases, such as stretchy rigs, a predetermined length value controls the current length of your limb. So a multiply divide node is required to be input before you begin your stretching calculations. And this is so in order to account for any offsets in that starting length value. And then fixing a cycle. So yeah, that little red or that little yellow bar, you're going to get that whenever there's a cycle. And so an example of a cycle forming is when you have a stretchy leg and you have your distance locators point constrained to your following leg joints. And so the cycle is that those locators control the distance measurement that determines the length of the joints. One separate transformation cannot be calculated to allow the others to be calculated, causing an inaccurate behavior and a cycle. You can fix this by locating the problem child first. In this case, the most flexible node and crux of the example is the stretch locator. So next you're going to want to relocate it and connect it so it can affect the hierarchy without being in the hierarchy. So in this example, don't put the locator on the joint, put it on the control. The control exists outside of the calculation and simply manipulates it, and it can be a pretty common solution to all cycles.
I can also just kind of go into an example that I have for cycles. So I'll just pull up the Maya scene that I have opened. If I can find the right window. Okay, here we go. You can see the Maya window, and it's not like buffering or anything.
Yeah,
Yeah, fine.
Okay, dope. So at the moment, we have a just kind of a pretty typical stretchy leg. I just have joints enabled since that'll probably be the easier way to show it. So at the moment, these stretch calculations, this is an older rig, so it's pretty messy, but more or less, it's in its PV mode. So I have two modes for the leg, and you'll see that I have the thigh to foot PV locator, and if I disable this point constraint and move it around, you can see that it stretches the leg essentially. Um, well, first of all, I found there's another reason why this is an old rig. I found out a way to basically the problem that I was running into was that the foot bank was originally the control had a point constraint on these end locators to allow it to stretch around and such. The problem that I have is that my reverse foot setup is occurring below this, so any transformations that occur in this area will not be accounted for stretching. Um, so originally, what was happening was that the tilt was happening and it wasn't stretching because the rotations were happening below this parent constraint, and the issue. So of course I was thinking, okay, the fix to that would be to first I'm going to find the right locator. Was to grab it and put it under the proper p-pole vector joint. So I put it under here. Let's see. And a cycle should be occurring. But there we go. So as soon as I start moving it, you saw that there is a okay. You saw that there is a warning screen down here saying that there's a condition node that is in the stretch calculation that is going to be acting inaccurately. You can even see it acting inaccurately as I drag around the controller, because essentially this locator is controlling. Hopefully, okay, good. This locator is controlling this distance node to be evaluated. However, the problem is that this distance node is going to use these two locators, and it will be eventually shoved back into the scale Y of these two joints right here. And it cannot accurately depict that because one transformation data that is required is this locator. However, that is not accurately determined to create this proper length value and create the proper scale values, because one value is involved with it's kind of confusing to describe it at first, but basically the stretch value right here is undetermined, is determined by this locator right here, and this locator is, as you can see, just kind of fumbling around, and it is oh boy, trying to figure out how to explain this properly. It's basically creating a active value that's being manipulated, and it's causing a lot of inaccurate transformations in the knee because of because it is kind of it's kind of as if you made these translation values kind of question marks. It's kind of making it doesn't have a determined value that is outside of this cycle that is allowing it to kind of cycle around and determine what this length value is, which will go through the entire node setup that I have for the stretchy leg that will determine the scales of these two joints in a way. So that's kind of the problem that we run into, and the solution is either to, I'm just going to kind of go back here for a bit until it cycles back. The solution was to kind of was one to kind of just separate it entirely from the hierarchy and connect it using constraints. That was just what I used at the time. And the solution that I came up with was grabbing the reverse foot joint that is basically at the ankle and point constraining it to all of the end locators here, because I have one for a pole vector end, I have one for a no flip end, and then one for knee snapping ends. So I would want to properly constrain those three joints right there. And another problem that we would run into is the double transforms. I'm going to use the example of the IK spline, because I do have that in the spine, and I just need to go and pull that up really quick. So here's the spine curve. I'm going to reveal it. It's right there. And in the attribute editor, its inherit transform is off. So if I turn it on and I try to scale it up, there should be some problems with how I scale this rig because of that. That should be causing some problems. And yeah, you can definitely see some problems that are occurring in the head because of how I've set up. Well, first of all, the spine joints are kind of scaling down at a rapid rate and receiving a bunch of double transforms, which is reflecting into the head rig that I have. I'm going to open up the node editor really quick so I can show another problem that you need to use to, another problem you need to solve with this case. Okay. So if I go over here, you can see that this is basically the spine curve that I have for my IK handle, and I have basically the curve info and then a global scale for that will account for this. Normally, if we weren't having any global scale, this info would go straight into here, the spine normalize divider node. But then I added this in later to account for the global scaling. And that all a global scale node really is taking one of your scale values and putting it into the input 2x and dividing that by the current value. So you can, because we're using this to stretch the spine, and you need basically a starting value to go for with your calculation, and then you can use that to further divide it and how you can determine the length of your spine. So that is those are kind of like the two solutions to those kinds of situations that you'll run into with a global scale. I'm going to go back to the presentation really quick, but yeah, I can totally address questions after we go through the presentation if you have any on them. Um, so um, next is generally some more organizational tips. You can see the presentation, right?
Yep.
Okie dokie. So a common thing you'll find yourself doing is when you're organizing your controls is locking attributes, color coding them, and grouping them together. A thing that I tend to do, and I've seen pretty commonly on a lot of rigs, is a bunch of visibility attributes on important controls to kind of lock off minor regions of controls. So like your head control will have a couple visibility attributes for your face rig, or you will have a IK/FK switcher control that may hold a bunch of visibility attributes for bendy controls, or sometimes FK finger controls, just so you can really reduce clutter. So you also want to make sure these attributes are not keyable. So when you create your attribute, you'll have a keyable, displayable, or hidden mode. Displayable allows it to have this gray bar, which means they're unkeyable, and they're basically a binary on or off throughout the entire scene. You don't want to have to deal with like a keyframed visibility attribute across the scene, because that can get annoying. Next, you'll want to lock your attributes. This is also a pretty quick thing, but in your when it's near where it's complete, you'll want to lock attributes that your rig is that are on your rig that can break your rig. So a great case is buffer groups, because a lot of animators will just to make selection processes easier, they will select the control and then do whatever they want with it, and then use the up and down arrows to navigate through the rig to find the next control in that hierarchy, especially with like FK arms, legs, or fingers. So you'll want to lock those areas off so you don't have to worry about an animator accidentally keying a buffer group and breaking your rig, or keying a buffer group and causing a lot of problems with animation, because they basically have two transforms going into one control. So a quick process is that you'll want to select all of your groups and just mass lock a lot of your attributes. And this kind of ties into into a slide that'll appear later on, but you'll want to make sure your groups have similar naming conventions so that you can just go into your selection menu up here. That's where you can change your workspace, or where your Autodesk ID is, or where certain specific tool sets are. You will have either an absolute transform or relative transform, which is just a box, which is just 3 boxes for the 3 axes, or you'll have just 1 bar for rename or select by name. Asterisk is a very good key to use pretty often when it comes to selecting things, because you can just type in *_group or whatever your suffix is, and it will select everything with that suffix no matter what comes before it. And then you can just lock and hide all of the attributes that you need, or just lock and hide every attribute in general. And then you can do the same for _control, for example, to lock and hide all those appropriate attributes. Finally, another thing is color coordination. So and control layers. If you're not using a picker, I recommend using using a display layer for your controls, also for geometry. A lot of rigs that I've seen just also manually set that geometry to be referenced, or in reference mode, so you can't select it even if it's like in a certain layer or whatever. It's definitely safe. It's a good idea for keeping your display layer area clean, and it's really handy if you're just using pickers. So the problem that you run into initially with setting up control layers is that if you set the color on the transform node of your controls, so you just kind of apply it to, if you select your NURB circle and use like this script down here and color it, it would be overrided when you put it under the display layer, because a display layer will pretty much set your control colors to default. So you'll want to make sure that you're coloring the shape node. Um, so this is kind of just a quick script that I was writing that you could totally use if you want to kind of change the colors of your controls. You'll want to select the general color codes to keep in mind are 6, 13, 17, 18, and 20. 6 is the typical like saturated blue. 13 is the typical red that you'll see in left and right controls. The number 17 is a pretty bright yellow that you'll see on IK controls, and the 18 is the lighter blue that you'll see in FK controls. I also put in 20 because that's kind of like the duller version of that red. It's a dull red. Um, I usually use a dull blue and a dull red for like bendy controls just to make things a little easier to distinguish between those between minors and major controls. What you'll first want to do is essentially select all the controls that you want that are, for example, FK controls, and you want to make them all light blue. You'll want to select all of those controls and hit the down arrow key so that you can go down into the controls hierarchy and select the shape node as opposed to the transform node. And then when you run this script, essentially, it will go through all of your controls. And first, it will enable the ability to color your controls by setting an override to the display's color, and then you'll set an adder on that override color, which is typically a slider bar you see in that menu. I can show it in a second, and it will go through that like color code and properly give it a color. But Dara, if you'd like to finish it up.
Of course, Brandon. So this kind of goes without saying, but having consistent naming, just like re-emphasizing that you should have that in your rig, and that's kind of like that should be your workflow. You should, and when you name things, have it very consistent across your projects. So having like the right or the left initial in front of your naming, and then like kind of like the underscore group or underscore joint, IK, etc. And keeping those things consistent so that you can, as Bren had previously mentioned, you can go through and select all of those things at a time, or kind of just keeping your things very organized, and it'll help other people kind of go through and troubleshoot your as well. So it'll help yourself, it'll help other people. And then lastly, kind of document your issues as you go. This can be kind of a part of your workflow. Essentially, whenever you come across like an issue, especially one that takes you a while to fix, essentially you can like take notes of these issues and your process so that when you end up fixing it, you can always come back to your notes in the future if you come across a similar problem. So I know Roman likes to take his notes like on his computer, and he likes to include like screenshots and scripts and like things to resolve that issue. I like to write things down in a notebook, but it's kind of like journaling, and honestly, I do refer to that like a lot. So your future self will thank you. And yeah, that's essentially it.